2. Getting there.
Yes, we are.
I don't know where we're going, but we're getting there. How's it going, Tom?
Doing well.
Good.
I've been following the hurricane news as of the past few weeks. That's pretty much what I do every day.
Yeah, I can't break the routine. There's always more hurricanes. That's the thing.
Yeah, there's always another one.
Yeah. Well, Jose is still out there.
Yeah, Jose's still coming. We're going to feel those effects tomorrow and Wednesday, I think.
Yeah.
And then we got Martha, right?
Maria,
not Martha. Maria.
We were talking about another Martha, that's why.
Oh, yeah, we were.
Yeah.
But Hurricane Maria is about to smash into Puerto Rico again, right?
Yeah.
So that's not very good.
No, very unfortunate.
And then it's coming up our way again.
Yeah, could be. We'll have to keep an eye on that one for sure. Jose Rains should be arriving here on Long Island tomorrow. Surf has been pretty swell. You going surfing, Tom?
Swell.
Pretty swell. Yeah. Tom, have you ever surfed?
No.
Me neither.
Never done.
Yeah. Kyle?
I think it's too hard.
Big thumbs up by Kyle. Very nice, very nice.
I saw a video of a guy surfing with his dog.
Really?
I've seen one of those. Pretty cool.
That's awesome. Yeah, maybe mushy. I mean, just get him on the board. He's ready to go pretty much. Look at him. He's out over there.
All right.
Thank you guys for joining us. This is, of course, trèSci Weekly, our weekly video podcast science news show where we talk about trending science. First, we actually give you the illest and realest royalty-free music for about 10 minutes. Then we talk about the trending science news of the week prior. You can always watch this show live as we record it on Monday nights at 8:30 p.m. We encourage you to do that because that way you can chat with us in the YouTube live chat, and we can answer questions and get some of your feedback as we go along. If you can't make the live show, no big deal. You can always catch the show for free on our YouTube channel. And if you like the show, please consider subscribing to us and maybe giving us a thumbs up or a like on these videos. It helps grow the stream. You can always, of course, follow us on Facebook.com/trèSciWeekly. You can follow us on Twitter.com/trèSciWeekly. And you can always, if you're feeling extra generous, support us financially on Patreon.com/trèSciWeekly. And we would very much appreciate it if you consider doing that kind of stuff.
And don't forget to tag us in any science news you find. This past week, Ryan Nash tagged us in a few things. One was about you can see live on a map all the earthquakes that are happening on Earth, even down to like a magnitude 1 and 2, and they're like all over the place.
Very cool.
So that one was pretty cool.
Nice little useful tool.
Yeah. So I appreciate that.
Yeah, I think he tagged us in something Cassini related, Tom.
Yes.
Also, which we will obviously be discussing as that's the top story.
That's our main story
this week. Anything noteworthy, unnoteworthy that we should talk about before we get on into the news?
Nope. I just wanted to mention about the hurricanes and how we're watching out for those.
Yeah.
I think that's about it.
All right. So then without further ado, we will get on right into it. So the first story is, as we mentioned, about the Cassini spacecraft.
So why are we talking about Cassini?
Well, it's dead now. Rest in peace. The mission has ended.
Yeah, if you've seen it previously on trèSci, we've talked about Cassini quite a few times, and I think we mentioned how it's going to go through its final dives in between the rings and then eventually crash into it. And we said this many times that it's eventually going to crash, and it finally has now.
Yes. So let's get on into it. Number one, NASA's Cassini spacecraft completed its 20-year mission with the grand finale of plummeting in towards Saturn's upper atmosphere and meeting its ultimate demise.
As we were talking about 20 years, you had told me that it took 7 years to get there, and then it was a 13-year-long mission when it finally got to Saturn.
That's correct. Yep. Many mission extensions along the way. I forget exactly what the original plan was.
It wasn't for that long, though.
No,
right?
no.
They just kept getting extensions.
Yeah, the science kept coming, Tom.
Yeah.
The science kept coming. The reason for ending the mission in this fashion was due to the spacecraft running out of fuel reserves, and so as to not contaminate any potential undisturbed surfaces on Saturn's moons or rings with a crash landing. Right, so this was something that when we first brought up the grand finale orbits and sort of the way they were going to end the mission by having Cassini plummet into Saturn itself. We basically pointed out what NASA, wanted to do about
ending
this.
The mission,
Ending the mission. And it's kind of an interesting thought, right? Like, well, what if there is some sort of microbial life or some kind of life that is existing on Saturn's moons in these, crazy conditions that are so unlike Earth's conditions? We wouldn't want our, lander or our, spacecraft to possibly contaminate it and then destroy it. So,
it seems like a little conservative to me, though. Like, how much effect is like smashing something into an object really going to have effect on the overall life of it? But you got, like, it's just taking everything into account. And they're just saying you might as well smash it into the planet as opposed to where these other delicate conditions exist, kind of.
Exactly.
On the moons where you don't really want to disturb that system. Right.
Yeah, all in all, probably nothing would happen. But,
really, but you never know. Yeah.
But why chance it, right? At 7:55 a.m. Eastern Time during a NASA live stream from Mission Control at JPL in Pasadena, California. Program Manager Earl Mays officially called the end of the mission. Tom, did you watch the live stream at all that morning?
No, I did not get a chance to.
I was up at the wee hours of the morning. I was up anyway. Managed to get good enough cell reception while I was out east working. Pulled over for a few moments to watch it. Nice. It was a somber moment. You could see everybody was really sad about it. I can imagine.
The mission's ending.
Yeah, these people have spent 20 years working on this project, and it's like sending a child off to college, except that child's not coming back from college ever. So
they smashed into Saturn.
So probably a sad moment for all of them, but it is what it is. It had to happen. Right? Yep. So there was a little video that NASA put together that we can watch. It was called "Goodbye Cassini." It's only a minute long.
Let's check it out.
Kyle, if you would be so kind as to let me know when to hit play here.
Congratulations to you all. This has been an incredible mission, an incredible spacecraft, and you're all an incredible team. I'm going to call this the end of mission.
Tom, are you crying?
A little bit.
Just kidding. So there you go. Kind of sad moment, but all good things must come to an end.
Yeah, it's a pretty amazing mission, honestly.
It really is.
I didn't really hear about it as a younger person. When I was trying to think about it, growing up, I didn't really
Me
hear
neither.
about this at all, right?
Yeah, I mean, I didn't really follow this kind of stuff as much as a very young man. But yeah, I'm surprised that it didn't make more of a splash at the time
when it started happening, right?
Yeah, but there you go. So I thought kind of a nice little tribute here at trèSci. What we could do is go through some of Cassini's top discoveries, right? So
Sounds good.
I compiled a list of top 5. Right, so we don't want to spend too much time here talking about it.
Brought back a lot of data.
Yeah,
we could be here for a long time.
Yeah, countless discoveries, still more to be made, I'm sure. But
yeah, they're not done digging through all that data.
No, of course not. So so let's go through them. Number 1, Not all rings are created equal. Saturn's rings vary in size and distribution, ranging from dust-sized particles to mountain-sized chunks of water, ice, and rock. The rings are named A through G in order of their discovery, not in order of kind of where they are position-wise. And each orbits Saturn at a different speed. While the overall origins of the rings are still under scientific investigation, Cassini observed the unique mechanism leading to the formation of Saturn's E ring, the outermost letter-designated ring. So that's not including the Phoebe ring, which we'll talk more about in a few moments. Turns out that Saturn's moon Enceladus undergoes cryovolcanism, spewing out water ice in plumes from within the subsurface that form the diffuse E ring. And we have a photo to show you guys. Obviously, credit goes to NASA, JPL, Space Science Institute, Cassini for this one. I'll bring it up on our computer here, Tom.
Sounds good.
So, so this is Saturn's E ring that you're seeing, the arc here on the right-hand side. And if you look kind of right towards the center of the bow here, that is Saturn's moon Enceladus, and the plumes of water ice that spit out from the subsurface of that moon feed into this ring system.
That's pretty cool.
Yeah. So this was a big deal because it means that rings can form in various ways, right? Like it's definitely not how the other rings formed.
Yeah.
So
that's pretty cool though.
Yeah, definitely an amazing photo there.
Yeah, at first glance, a lot of people don't realize that the rings are actually made up of individual particles.
That's true.
Because they look solid. Even if you look at it through a telescope, it looks like a nice band, but it's made up of little chunks.
Yeah. Bands that make her dance. Tom, I don't know if you've ever heard that classic song.
Yes, I have.
Number 2 on the top 5 list. Saturn has a hexagonal polar storm.
Hexagonal.
Hexagonal?
They're both accepted.
Okay.
Yeah.
Thank you. Saturn's north pole sports a 6-sided hexagonal storm structure that is somewhat similar to a hurricane on Earth, and we've been spending a lot of time talking about hurricanes here on Earth, Tom. According to Andrew Ingersoll, Cassini imaging team, quote, "The hexagon is just a current of air, and weather features out there that share similarities to this are notoriously turbulent and unstable. A hurricane on Earth typically lasts a week, but this has been here for decades, and who knows, maybe centuries," end quote.
It's pretty crazy that something made up of air would have such a rigid type structure like a hexagon, right?
Yeah.
Pretty bizarre stuff.
So we have a short GIF of the hexagonal storm here. Is it already up and running? Oh, beautiful, Kyle. Very beautiful.
Nice.
So what we're looking at here, right, we're looking from the top down. This is Cassini's North Pole. Mm-hmm. And, if you look closely enough, you can basically see what we would kind of call the eye of the storm at the very center there. Similar to what we've been looking at with Hurricane Irma and Hurricane Harvey and now Hurricane Maria.
Yeah, that would probably be low pressure in there, I would imagine.
Yeah.
Of some sort.
The different colors in the stitched together Cassini images correspond to different wavelengths of light and thus indicate different atmospheric particle sizes inside the hexagon. Smaller inside versus outside the hexagon, which would be larger. Right? So you can see there's like a clear distinction here.
Yeah. Where
the 6-sided jet stream kind of can move around smaller particles. So, unique.
Yeah, pretty crazy that that's just on Saturn. Who would have thunk?
Who would have thunk it? And you really don't see hexagons in nature, really, that very often. So, strange.
Especially when it's air, right?
Yeah. Yeah, exactly.
Something that could easily flow around, being a weird shape like that, is something else. Who knows what's really going on there?
Yeah. Number 3 on the top 5 list. Titan has liquid methane lakes.
And Titan is
Saturn's largest moon.
The biggest one.
Yeah. Radar images capable of looking through Titan's opaque atmosphere were able to determine the presence of liquid methane and ethane lakes on its surface. And we have an image of that radar image for you as well, courtesy of NASA, JPL-Caltech, and Agenzia Spaziale Italiana, and the USGS, Tom. Lots of people went into to making this image happen here. This makes Titan the only other object in the solar system besides Earth that is able to sustain surface bodies of liquid. Most of the 32 named lakes are geographically located near Titan's North Pole, but one of them, Ontario Lake, is located near the South Pole. And the Huygens probe, which separated from Cassini and touched down on the surface of Titan in January of 2005, did not find areas of liquid hydrocarbons near the equator, where it touched down, but did find evidence of past drainage channels and potentially even a dried up shoreline, indicating that there was flowing water on the surface near the equator at some point in the recent
flowing
history.
methane.
That's what I mean. Yeah, not water. Excuse me. That's a big no. That's a big no-no.
But still, being able to have liquid at the surface, pretty conducive to life.
Absolutely, yeah. And I mean, just weird to think about methane as a liquid. Yeah, like it's always a gas here on Earth due to our conditions, but it's so cold there that it is in the liquid phase. So
yeah, it kind of reminds me of like the story of people. You know, it matters about your conditions that you start off with.
Yeah.
Because whether you're water somewhere, liquid, you're a gas somewhere else, man.
Number 4 on the top 5 list. One Iapetus mystery solved, another Iapetus mystery raised. So this one's a little bit of a long one, so stay with me here. Saturn's moon Iapetus has a distinct two-tone coloration that stumped astronomers for many years. And we can bring up an image here
of
Iapetus. This is actually going to be kind of the whole story here. But Iapetus down in the bottom right, you can see it's got this kind of charcoal dark color on the face that we're looking at. But the poles, right, are kind of this brighter color. And that's how it is on the backside of the moon if we were to be able to kind of rotate it around. The key to this distinct feature actually derives from one of Saturn's other moons, Phoebe. Phoebe is different in composition from Saturn's other moons and orbits in retrograde, meaning backwards relative to the other moons. Right? So if they're all going around like so, Phoebe goes around the other way. This indicates that it is likely a captured Kuiper Belt object rather than a moon that formed within the Saturnian system. In addition, NASA's Spitzer Space Telescope was able to determine the presence of Saturn's outermost ring, named the Phoebe ring, due to the fact that the ring orbits in retrograde, just like Phoebe itself, and is likely formed from particles that are ejected off of Phoebe's surface as a result of micrometeoroid impacts. Right?
So that's why it would be orbiting in retrograde motion as well.
Exactly.
If it came from Phoebe.
Yep, little chunks of debris from maybe the asteroid belt or the Kuiper Belt or just within Saturn itself, other moons, whatnot, blast into Phoebe. Phoebe, much smaller moon than many other moons, so not a lot of gravity to hold the pieces to its surface, and so these pieces get spewed out into space and end up in this ring-like orbit around Saturn itself. So now here's where it gets interesting. How does this relate back to Iapetus? Well, since Iapetus is tidally locked to Saturn, like our moon, how we only see the same face of it, right?
And that's why you hear the dark side of the moon.
Exactly. The leading side plows through the Phoebe ring debris, collecting it on the surface, causing the one side to appear dark and dirty. This also attracts more sunlight to the dark side, causing surface ice to sublimate and move to the trailing side, which causes it to appear brighter. So that is the mystery solved, right?
Because of Cassini.
Yeah, Cassini basically, put all the pieces into motion to figuring this whole puzzle out.
So it was basically moving through a whole bunch of space dust.
Yeah.
That made it a certain color. And then being a different color, it absorbs light differently. So then it made the ice go to the lighter side.
Exactly. But in doing so, right, Cassini taking all these pictures, trying to figure all this stuff out with all its sensors and whatnot, now we have a new problem, right? Iapetus also has an equatorial ridge, and the formation process of which is still unknown. And we have a picture of that to bring up as well. Of course, credit goes to NASA JPL for this one. So here is Iapetus's equatorial ridge. It's basically
looks like a mini mountain range.
Yeah, it looks kind of like a mountain range that basically goes around the entire moon at the equator. And with Iapetus's kind of orbital incline, it doesn't even really make sense that it could be like a tidal pull at the equator from Saturn. So there's a lot that goes into understanding this. Probably has something to do with the way this moon formed, but still under lots of scientific investigation here, Tom.
Gotcha.
It's pretty cool.
Yeah.
Looks like a walnut, if you ask me.
Yeah, it actually kind of does. Kind of does.
And number 5 on the top 5 list, Enceladus is an ocean world with hydrothermal vents.
I think this one was one of the more profound discoveries, and they made a big hype about it. But it's kind of an interesting one because it's such a crazy environment for life to exist, and it does here on Earth. So pretty cool that it happens out there.
Yeah, definitely. And we chatted about this.
Yes, we did. We mentioned the hydrothermal vents.
Way back on trèSci Weekly, episode 11, before we even gave them titles.
That's true.
That's true. We discussed a NASA press release confirming the existence of molecular hydrogen in the plumes of material ejected from the subsurface of Enceladus. We have an image to bring up for that one as well. This is the same image that we brought up way back when on the previous show. This process is potentially similar to the same process we observe here on Earth, where hydrothermal vents on the ocean floor provide chemical energy for microbes in the form of molecular hydrogen. Could Enceladus' subsurface ocean be the source of energy for microbial life as well, Tom?
How do we know for sure?
How do we know for sure? Well, as our good friend John Locke would say, we have to go back. Right?
We have to go back.
And that was kind of the theme of the closure of the Cassini mission, was that all of the scientists working on this project for 20 years now, there's this yearning to go back, right?
And continue the research.
Yeah.
Right?
20 years ago, our technology
was kind of poo-poo.
Yeah.
No offense.
Yeah. I mean, NASA obviously had
The
state
best
of the
of
art,
it, yeah.
but I think, you could just send an
times,
iPhone out there and it would be, higher resolution camera and that sort of thing. So
yeah, technology's crazy in that regard.
Yeah. It's very cool. Any last closing words?
Just last words about the hydrothermal vents on Enceladus. It's kind of crazy to think about life existing in the hydrothermal vents, because the whole system on Earth, right? We get all of our energy from the sun. That's where the plants get their energy. The things that eat the plants get their energy from the plants, and this whole system really all depends on the sun. And then you got these guys on the bottom of the ocean, just some hot minerals, and you got microbial life, and then you got little things that eat those microbial life, and they all exist, and none of them know anything about the sun.
Yeah.
Just this weird little chemistry in the ocean.
Yeah.
It's some wild stuff.
Definitely, yeah.
So definitely a possibility on Enceladus.
Yeah, why not, right? Moving on.
Rip Cassini.
Rip
in the chat.
dream. Rip in the chat.
Can we get some RIPs? But also in the chat, Carrie Kalita mentioned that a natural occurrence of geometric shape are beehives are hexagonal.
That's true.
Just like Saturn. Maybe it's a giant beehive. That's where all the bees are going.
Maybe the rings are made up of chunks of water ice. They're actually just bees. And tons of bees. I think we're onto something here.
That we'll have to...
Number 2. On Thursday, September 14th, the 2017 Ig Nobel Prize award ceremony was held at Harvard's Sanders Theater. Tom, are you familiar with the Ig Nobel Prize ceremony?
No, I was not.
Okay. Did you watch this one? I sent you the link.
Yeah.
Okay, cool. So for those of you who are unfamiliar, the Ig Nobel Prize is sort of like the Nobel Prize, but it's the opposite, right? So the Nobel Prize is like this really prestigious award that is given out to researchers.
The most standout research, the most impactful research.
Exactly. The Ig Nobel Prize is all about what seems to be like really silly and menial research, But
that
then
you can get something out of it.
Yeah, but then kind of makes you wonder a little bit afterwards. According to the Improbable Research webpage, the founders behind the event, quote, "The Ig Nobel Prizes honor achievements that first make people laugh and then make them think. The prizes are intended to celebrate the unusual, honor the imaginative, and spur people's interest in science, medicine, and technology. Every year in the gala ceremony in Harvard's Sanders Theater, 1,200 splendidly eccentric spectators watch the winners step forward to accept their prizes. These are physically handed out by genuinely bemused, genuine Nobel laureates," end quote. So, if you've never watched it before, it's very silly. It's a show. It's less of an award ceremony, more of a show.
Yeah.
It's full of traditions, such as the throwing of the paper airplanes onto the stage, the little girl who repeatedly says, "Please stop, I'm bored," when speakers go on for too long, etc., etc. And yeah, so I watched it. It's about an hour and a half long.
Yeah, it's pretty funny.
You watched it? Yeah, it's pretty funny. But I thought we could go through the prize winners and sort of
mention what their research was.
Yeah, their kind of their research. So for the physics prize, the award went to Marc-Antoine Fardin for using fluid dynamics to probe the question, can a cat be both a solid and a liquid? And this was based on a paper titled On the Rheology of Cats by the same researcher. And so that kind of goes into... Oh, Kyle, by the way, can you bring up the picture of the flowing cat? Thank you very much. This question was actually something that was raised on the internet about cats, that they sort of, like a liquid, take on the the image. Nice, Kyle. Nice.
There it is.
Very nice. The cats take on
the
shape of the container that they're in. So, can they be deemed a liquid if we're talking about physics? And it turns out that yes, they can, based on their environment.
The cat can be considered a liquid.
Yes. So it depends. It depends on the the container you're trying to put them in. But yes, in this case, with the vase here, it's very clear
technically a liquid.
This is a cat martini. I want to try this.
This looks pretty funny.
Yeah, I mean, my cat's name literally is Mush.
He would probably look like that.
Yeah, he is a very flowy
similar
cat.
He's got a similar tail to this guy.
I know. He's adorable. The Peace Prize, Tom, was awarded to Milo Puhan, Alex Suarez, Christian Locascio, Alfred Zahn, Marcus Heitz, and Otto Brandley for demonstrating that regular playing of a didgeridoo is an effective treatment for obstructive sleep apnea and snoring.
Yeah, that's pretty interesting.
Yeah.
So when you have sleep apnea, your airways kind of close up while you're sleeping. And I actually recently went to the doctor for my sleep apnea, and I wear a mouthpiece at night, actually, to hold my jaw open so that your breathing pathways don't get blocked while you're sleeping. And you don't even know it while you're sleeping if you have sleep apnea.
Well, sure.
Even though you wake up.
Yeah.
But you're not aware of it.
Right.
So it's a thing that gets untreated for a long time in a lot of people. But you could just play the didgeridoo as well.
Have you ever considered playing the didgeridoo?
Not until now.
Not until now is exactly right.
Not until right here.
Because I happen to have
a didgeridoo. So it's an instrument that descends from like
Australia.
I think maybe.
I think it's an indigenous Australian instrument, and it goes a little something like this, Tom.
So it might help with your breathing passageways.
You know how this. It's basically the same instrument. Beautiful.
It's tough.
It is tough. Not easy. Kyle was jamming out before.
So yeah, somehow doing that helps your breathing passageways. Pretty cool.
I like that was the Peace Prize.
That's the Peace Prize.
You gotta keep the peace. No more snoring. The Economics Prize was awarded to Matthew Rockoff and Nancy Greer for their experiments to see how contact with a live crocodile affects a person's willingness to gamble.
So you're in a life-threatening situation, you see a crocodile, and now you're ready to risk it all. That's what they're saying.
It's as simple as that.
You know, like, I could die any day. That crocodile almost killed me.
Yeah.
Let's bet it all on red.
Yeah.
You know, one of those.
One of those. The Anatomy Prize was awarded to James Heathcote for his medical research study, Why Do Old Men Have Big Ears? And he made a very compelling point about it. He was like, you know, you see old men, they have big ears, you can't unsee it. Why do they have such big ears?
They just keep growing.
Yeah, they just keep growing, I guess.
Cartilage. A lot of time into the growing.
Yeah. They get hairier, too. I don't know if that should be a follow-up study. The Biology Prize was awarded to Kazunori Yoshizawa, Rodrigo Ferreira, Yoshitaka Kamimura, and Charles Leinhard for their discovery of a female penis and a male vagina in a cave insect.
That's what a lot of time and darkness. That was a joke. But yeah, that one's a pretty cool one.
Yeah.
Weird biology.
The Fluid Dynamics Prize was awarded to Jiwan Han for studying the dynamics of liquid sloshing to learn what happens when a person walks backwards while carrying a cup of coffee.
So you have a different sloshing motion as opposed to walking forward or walking backwards.
Yeah. So
should you walk to work backwards if you don't want to get it on your coat?
That is the best. That is the best way, right?
To reduce your sloshing.
What's funny about this is after they do the silly show, you know, with the opera and the you know, all the nonsense,
all the awards.
They do like a press conference style thing where the researchers come in and give a PowerPoint presentation on their actual study. And I was watching a little bit of this as well, and it was up to this gentleman who you know, was explaining, like, you want to grab your coffee cup with the claw, right?
From above. Yeah.
You don't want to hold it here or by the handle even. You want to do from above, and if you walk backwards, that has the least.
Less sloshing.
Yep, you get the,
So if you ever have a really full cup, I guess it could be any liquid, you're going to want to mosey on backwards to your room so you don't spill it everywhere.
Yeah. He did say that you could also just use a lid.
Oh, a lid.
So,
what a good invention.
Yes. There you go.
Darn it.
The Nutrition Prize, awarded to Fernando Ito, Enrico Bernard, and Rodrigo Torres for the first scientific report of human blood in the diet of a hairy-legged vampire bat. So,
a vampire bat eating actual human blood?
Yeah, that actually sounds pretty interesting. Could look more into that one, maybe. The Medicine Prize, awarded to Jean-Pierre Royer, David Moynier, Nicolas Torquay, Anne-Marie Moulet, and Tao Jiang. I definitely screwed up all of those people's names. Sorry for that. For using advanced brain scanning technology to measure the extent to which some people are disgusted by cheese.
How can you be disgusted by cheese?
Right?
It's so good.
It's so good. What's your favorite type of cheese?
That's a loaded question.
That is a loaded question.
I don't know. It's tough. Depends on what you're eating.
That's very really fair point.
All it is.
Very fair point. You don't put Swiss cheese on nachos, no, Kyle.
You usually don't.
Okay. The Cognition Prize, awarded to Matteo Martini, Ilara Bufalari, Maria Antoinette Stazzi, and Salvatore Maria Agliotti for demonstrating that many identical twins cannot tell themselves apart visually.
That one's kind of crazy.
That's crazy, actually. So.
You don't know whether you're you or your twin.
Who am I?
Who am I?
And finally, the Obstetrics Prize, Tom, awarded to Marissa Lopez Tejan, Alex Garcia Fuara, Alberto Prats Galino, and Luis Palares Aniorte for showing that a developing human fetus responds more strongly to music that is played electromechanically inside the mother's vagina than to music that is played electromechanically on the mother's belly. And believe it or not, they patented, or I don't know if they patented, but they developed an actual product
that allows you to do this.
That allows you to do this. It is called the Baby Pod. Kyle, if you wouldn't mind bringing up the baby pod image for me. Not the graphic one. No, I'm just kidding. There is no graphic one. The baby pod it's a real thing. You basically...
It's a little device.
Yep. You put it where you put it, and you plug it into your phone.
And you could just play music to your baby.
To your unborn
inside
baby.
your body.
So if you are pregnant right now...
And want your baby to hear music a little better.
Or better yet, I'm sure you could get trèSci Weekly to play on this baby pod. So if you want to give your baby a head start in science,
head start.
you can do this for the low cost of, I think it was, what, $165?
Yeah.
So,
I think so.
Yeah.
That's pretty funny, though. Those
funny.
Those are all, they get you thinking on.
They do get you thinking.
You could really be scientific and question almost anything when it comes down to it, you know? Like, you could think about the weirdest stuff. Like, these things made me think about asking the weirdest type of scientific questions. Like, why don't some people like cheese? You know, like, just weird questions that you never think of, but these are cool ones that might, you know, inspire innovation and weird stuff.
Yeah. I believe one of the, not from this past year's list of award winners, but one of the previous year's award winners of the Ig Nobel Prize actually has won a Nobel Prize.
Oh,
so
he's been on both ends of the spectrum.
Yeah, so
that's cool.
That just goes to show you, right? It's all about it's all just about the scientific integrity, not so much the study content.
The method,
right?
not the content. Yeah, it's how you do it.
Right. Kayla asks, do you have to be pregnant to buy?
I don't think so.
I don't think so. So that's good news for you. You better not be pregnant.
Oh, snap. It came out on trèSci.
It came out on the air. Oh, boy. Moving right along, Tom. Number 3. Back to serious science.
Okay.
Science. Not that much more serious. Also on Thursday, September 14th, NOAA's Climate Prediction Center issued a La Niña watch with, quote, an increasing chance around 55 to 60% of La Niña during the Northern Hemisphere fall and winter 2017-2018, end quote.
So, La Niña, El Nino, just to remind everybody, the general principle is that it's the cycle of the way the water temperatures go in the Pacific Ocean, so off the coast of California, extending out along towards Japan. It's sort of that area in between where it periodically goes from being colder in that area to warmer, and then so when it's colder it's a La Niña, and when it's warmer it's called an El Nino, and it just goes throughout the cycle. So it's never just like one temperature, so it's either more El Nino or more La Niña, because it's never like stationary.
Right.
We're never saying it's one thing. It's sort of, you know, the temperatures are always mixing around.
It oscillates.
In the Pacific Ocean.
Very cool. And this can have some measurable weather
effects around
pattern
the world.
Effects. Right.
Yeah, I mean, it makes sense. If it's colder in one area or warmer in another, that affects the weather in the area.
Sure.
Yeah.
The prediction comes based off of a below average sea surface temperature across the equatorial center and eastern Pacific Ocean over the last month, as you were just saying, Tom. We have an image to show you guys of that data. So
the blue is cool.
The blue is cool. The red is warm, and
so when it's right along the equatorial line, right, that's usually where it's cool. That's what we're looking for. That's the El Nino, La Nina area. Right.
So this is showing you above or below kind of the mean, right? So
blue is cool.
Blue is cooler, so we're now kind of below normal temperatures in this part of the Pacific Ocean.
And that's what we consider a La Nina.
Correct.
Yeah.
You can see all the way on the right-hand side,
that's
South America, and then Indonesia and Australia kind of on the left-hand side, lower left-hand corner here.
I actually kind of misspoke before when I was saying like California to Japan. It's actually at the equator,
right?
What we're looking at.
Yeah. Right. Yeah, it's a little bit more south than that, but so that's what we've kind of seen over the past month, and so the prediction is that we're maybe headed towards a La Nina.
So what does La Nina mean for us in the northeastern United States.
I'm glad you asked that, Tom. While weather patterns will vary among differing La Niña magnitudes, some commonalities for the United States include colder winter temperatures across the northern plains, upper Midwest, New England, New York State, and the West Coast, some increased precipitation or wetness over the Pacific Northwest, the Bitterroots, or western Montana and Idaho, parts of the Ohio Valley, Tennessee Valley, and drier and warmer temperatures across the southern plains, the Gulf, the southeast coast, including Florida, Southern California, and the desert Southwest. And we have one more image to bring up to go along with that. Basically kind of summarizing exactly what I just said there. So it could mean, Tom,
that we could have a busy winter.
We could have a busy winter in terms of snowfall, right?
Yeah, just in terms of the amount of precipitation that we'll get, as well as it being cold enough to snow.
Right.
At the same time.
Right. So that is just the prediction, whether it plays out that way.
This is like the general pattern, the La Niña, El Niño. And any sort of weather systems, like, it shifts the pressure a little bit, so it shifts everything a little bit, so we can sort of say this is the general trend. But like you said, with weather, like when we're looking at individual hurricanes and individual storms, it's tough to say exactly what we're going to get, but general trends and probability point towards wetter.
Right.
So
for us,
yeah, as opposed to drier down in the southeast.
Yeah. So we'll see how it all plays out.
Yes, we will.
And the last story here, number 4, Apple announced the iPhone 10 along with the iPhone 8, a third Apple Watch series, some other products at its press event on Tuesday, September 12th. Tom, you have an iPhone.
I do, actually, yes.
How do you like it?
I like it, yeah.
All right, cool. Kyle, you have an iPhone. Thumbs up, thumbs down? Thumbs up, okay. I have an iPhone, so I figured we would chat a little bit about this. A lot of people are talking about this. The iPhone 10, which is named for the 10th anniversary of the iPhone, right? Because it doesn't really make a whole lot of sense. It goes from 8
to 10.
To 10. Yeah, we were talking a little bit about, like, what are they going to do
with the next one?
Right, when it gets to the 10, right? If they go to 9. But Kyle's saying he doesn't think they're going to do 9. Or maybe you were saying that.
Yeah, I was thinking they'll start off with something new after the 10th anniversary. Just like a new system.
And you were saying they might just jump to 11. We'll see how it all plays out there.
Yeah, I think it's funny with all these things, like introducing a new phone. Because to me, it almost seems like it's time to introduce a new product for the market, not that it's time to introduce a new product because of innovations and things we want to put into it. Right?
Yes.
That's what I think it sort of comes down to.
Absolutely. We could just close this door. That's exactly where I was getting at with this whole thing. Right? So, I mean, the iPhone 10 features, right? Here we go. Will include an edge-to-edge OLED screen with HDR support, what they're calling the True Depth camera system, which includes an infrared camera, a dot projector, front camera, flood illuminator, and proximity sensor. So that's kind of nice.
All the camera stuff.
Face ID, facial recognition, which will replace the Touch ID on past models and does away with the home button. So no more home button. And other little perks like a wireless charging station, being waterproof, and something called Animojis, or little cartoon animals that replicate your face movements. So, I mean, that's kind of neat. All this can be yours at the low starting price of $999, Tom, and that's for the the basic model.
Yeah.
Of course, with iPhone, you can always get the crazy memory and all the doodads, and it'll cost you well over $1,000. Pre-orders begin October 27th, and the phone releases on November 4th, with supply expected to be extremely limited.
So there's going to be lines, people waiting out for it.
So, if you were in the market for a new phone, would you upgrade to something like the iPhone 10?
If my cell phone provider was like, here you go, we'll give you a new phone if you stay with our plan. Otherwise, I'm not upgrading to it.
Yeah.
Probably not.
That's how I felt about the phone that I have. Now, I have the iPhone 7 Plus.
Okay.
Which is...
That's like the newest one?
Yes. I bought it because my iPhone 5 standard bit the dust. Battery busted on me. Had to go get another new battery from the good friends over at Staples. Voided the warranty as I did that, of course. That battery then died. I think when I took it to the Apple store after that, they told me the processor had died on it. So I was like, all right, well, I need a phone.
Yeah.
You know, I can either buy the 6 for way too much money because nothing ever actually comes down in price at Apple, or I can buy the 7 for more money, but be, you know, probably set for a little while here. So that's what I did. But I just feel like there's no reason to upgrade ever.
Yeah, there's never really a good reason to do it. Yeah.
Like, I wish I could buy an iPhone 4 for $100, you know, like a new one, but that's just impossible. So there's that. A lot of comparisons being drawn to an old model of the Galaxy, the Samsung phone.
That had a lot of these features
already. Like, so that's kind of funny. I guess I'm not really... I like Apple products, but I'm not one of these diehard Apple faithfuls.
Yeah, me neither. I like my iPhone now, but I'm not like attached to it or anything.
Yeah, I mean, I am attached to it because I'm always freaking looking at it, which is maybe another reason to get rid of it altogether. But here we are.
Nash said that where he works, there's an Apple store, and a lot of people are talking about camping out again to get it, so they could resell it for more money, which is the typical. Yeah. That
especially if the supply is going to be as limited as they're projecting it
to
be.
So everyone's just going to sit there, wait, buy it, resell it. Typical.
I might do that, honestly.
If it's worth if you can double your money, sell it for $1,800. It's worth sitting around for a couple hours.
Definitely. Well, that's all the news, basically, Tom. Shall we move on to Tom's Corner?
Sure. I had a small little idea for this week.
Cool.
So, one of the things I follow on Twitter is The Economist. They're kind of like world news.
Okay.
And a lot of the stories they had were about the number of weather-related disasters increasing, as opposed to around like the 70s, 80s, and 90s. They're saying now we're having more weather-related disasters. But they gave like specific numbers saying like we have 400 times more than we had in 1970. And where that's one thing to look at, and we definitely need to keep track of how many disasters are happening and where and what is causing them, like what's the influence of them. I think at the same time we have to realize when we're doing studies talking just about sheer numbers of things like this is that we don't have a lot of data for a lot of years. So I think you can sort of missee trends in the data, and I don't think that the number that they're saying is the actual number, but I'm sure that there's more. But what the article also says is that with more disasters, we actually have less deaths now because of our construction and our ability to predict things and just knowing what to expect. So even if the number of disasters is going up slightly, even though they say here that it's 400 times more than it was in the early 1900s, I think really what they're getting is a lot of the impact of these events because of the amount of people living in these areas that are being impacted by these things. So I think it's slightly skewed, but I think at the same time we're also it's sort of part of the global climate theory, right? That we're going to get, they don't even actually say more storms though, they say that slightly less but more intense. So I'm not really sure where all of this is coming from. So it was just making me think that I think it's a lot of times easy to try and make claims about trends in data over the past 20, 30, 40 years, but a lot of times I think you end up misrepresenting the facts a little bit. So this one was kind of weird when I was looking at it.
Yeah. This is it's an incredibly difficult thing to put a hard number on. Because
we haven't been looking at it for that long, and then it's affecting where people are as opposed to where they're not. There's more people here.
Yeah, and the instruments that go into evaluating,
and really tracking them are new, right?
Especially with storms and for goodness sakes, we don't even have a very good way to evaluate the size of a crowd, right? Which we learned not very long ago. So
a lot of times these things are hard to get good hard data numbers and model them and get correct things about them.
Yeah, and if we're talking worldwide, here in the United States, we have a very proficient Census Bureau that accounts for all the population sizes in various areas of the country. That is not the case in
the whole world.
Whole world. In some of these more poverty-stricken areas where there are a lot more deaths because the infrastructure isn't built to sustain a natural disaster like an earthquake or a mudslide or something of that nature, I'm sure there are people that just never get documented as being a part of the statistics here. So I think there's a lot of uncertainty involved with these types of things, and like I said, it's hard to put a hard number on this. I shared with you an interesting article by the Wall Street Journal. This was an op-ed by a gentleman named Ryan Maui. I don't know how to pronounce his last name, but I started following him on Twitter during the Hurricane Irma tracking because he's a meteorologist or an atmospheric scientist. I don't know what his exact degree is in. But he wrote a very interesting article that says that the climate agenda is being fueled by people kind of pointing to these more frequent storms that we've seen over the past month. And
they just want to point to it and say it's because of the warming.
Right. But
that's not really the case, right?
That can't possibly be just discerned within the 5 minutes that it takes to post something like that on Twitter. And so climate science is really going through such a weird, turbulent period in history right now.
Yeah, like people want to say this about this, and then they want to say this about because of this hurricane, and then this happened, as opposed to realizing what the science is and how it works and how long it takes to understand things on the geological Earth timescale, right? Mm-hmm. Where we live our life in a span of 80 to 100 years, and that's it. Whereas these trends are things that take sometimes thousands of years to fully happen, basically. So it's hard to say on timescales of our lives what is actually being caused by the warming and why are there more storms. Like you said, it's so hard to say within our own timescale, where we want to say this storm is because of this for this reason, whereas you're just one person. It takes a lot of data from a lot of years and really knowing what's going on.
Right.
So it's tough.
Yeah. And the other thing in that article was there's a lot of claims being made of like, well, this Hurricane Irma was this amount more devastating than it would have been if climate change wasn't a thing.
And you can't say that either.
You can't say it because how do you measure something that wasn't? Or at least, I don't know, how do you do that within less than a week of it actually occurring? You can't. These are really, really these take thousands and thousands and thousands of simulations and models to go into saying what the strength could have been under different conditions leading into the whole thing, and I don't know. It's
still even unclear at that point.
Exactly.
So, on the one hand, we know the climate science pretty well, but I also wanted to bring up this point, saying that, like, to the point where you need to be careful with what people are allowing to be said about the climate change and the global warming issue, where it's so easy to want to point fingers to it because it's the accepted science and you just want to say it's right because of this. Mm-hmm. But you don't have to say it's right because of this when it's not that. you don't have to keep making arguments for global warming. We're recording the temperatures, and you don't have to keep saying this is because of that. Because then once you start having misrepresented facts about climate change itself, then that kind of just puts it in a weird position where it's already under so much scope because of politics, where it needs to be really clear with what they're saying to people. Right? That's kind of the point I wanted to get out.
Yeah. Yeah, I mean, I think...
Because we're going to be talking about more hurricanes again next week. I mean, they're coming and happening, but, I mean, you want to say it's because of climate change, because that's all anybody talks about.
Right.
But when you think about the real science of it, you can't just say this is because of that and this and that. It's complicated.
And I get it, because...
You want to say, we're right. This is it.
It vindicates you, right? There are people that refute that the climate is changing, and this is your chance to be like, aha, you see?
But that's not even the case.
But that's not what's happening either. So
it's a little gray area to be in.
Yeah. So, as I've said to people that refute climate science and the fact that the climate is changing, let the atmospheric scientists, let the climatologists, let the meteorologists, let them do their job,
the data,
right?
And,
they're the ones that know.
Not a few minutes of reading things online.
Exactly.
It's tough to really get what's going on in this system.
Yeah.
So then the last thing I wanted to do was, let's go over some of the records on Earth right now. Forget warming in the future. What has the Earth already seen? So what can we be looking to watch for in the future?
Cool.
So I wanted to look at just some of the records. So the low temperature for the coldest summer was in Greenland, where the average temperature was minus 27.4 degrees Fahrenheit in the summer.
That is cold.
That is pretty cold.
Real cold.
And then there's some pretty cool rain records. So for the most in 1 hour is actually, I was telling you, Missouri in the United States, in 42 minutes it rained 12 inches. So a foot of rain in 42 minutes.
Can you imagine that?
So Kyle, could you actually bring up Wikipedia and just bring up a list of weather records, if that's possible? Because I feel like as I'm reading through this, it's easier when you're looking at it.
Mm-hmm. A foot of rain in 42 minutes.
In 42 minutes, yeah.
High school
foot of rain.
You
fell.
start math class in high school, and by the time math class is over,
it rained a foot.
It rained a foot.
In Missouri, that happened once.
Man, that's crazy.
Right? So here's another thing we were talking about with records. When you just talk about records, we don't have that much to talk about. So yeah, we have these extremes, but we don't really know how extreme they are relative to climate.
Right.
Really. Because we don't have thousands. Well, we know from ice cores a lot of temperatures, but beyond that recent history, it's tough.
There's a difference between extrapolated data and recorded history, right? So
that's why it's cool to look at it every once in a while.
Yeah. So what else we got?
Just making sure, Kyle, we got that up. Working on it. We're doing it. So that was a little bit about the temperatures. We talked about rain a little bit. The most from a single tropical storm was 253 inches in Réunion. We looked up where that was. That's just off the coast of Madagascar.
Yeah.
So from one tropical storm, let's do 253 inches to feet. Do that on Google real quick. No, come on.
Go to Wolfram Alpha, probably.
Do it real quick.
It's already done.
21 feet of rain.
21 feet of rain, ladies and gentlemen.
In one tropical storm.
On an island. How is that island still an island?
Yeah, I don't know. That. I guess it has like mountains that are all just roads off of it into the ocean. Maybe. I don't know. That's some crazy records.
I'm gonna do some research here. Island of Réunion.
Is it gone?
It's not there anymore.
Yeah.
Things to do in Réunion.
Drown.
Yeah, drown. You're right. It is lots of mountains.
Yeah.
Lots of hiking.
Yeah, I guess that's about it.
There you go.
But that's an amazing number. Just 12 feet
Yeah.
of rain.
Jaw-dropping.
From one storm.
Yeah.
And that's actually happened. You know, this is no speculation. These are measured phenomenon. Let's just go over a few more. Where did I have that up? Are we gone? We're going back. No, we're not.
Isn't that time?
There we go.
Hey, we found it.
So, a little bit about snow. The most in 1 year was 102 feet in Washington in the United States on a mountain, obviously. So all the snow records are on mountains.
Mhm.
So they're impressive, but
Yeah.
not as cool.
Makes sense.
Yeah, I mean, it snows in the mountains. Fastest wind speed ever recorded was observed by a Doppler on wheels radar unit in a tornado, and it was 302 miles an hour, plus or minus 20,
Jeez.
because of some uncertainty.
Yeah.
So 302 miles an hour. That's pretty crazy, though. So the fastest wind ever recorded was in the United States. And then the fastest daily average, so over a day, their average was 108 miles an hour in Antarctica during a 24-hour period.
Wow.
So for the whole day, it was 100-mile-an-hour winds.
That's
So
crazy.
then, a little bit about tornadoes. The deadliest tornado was in Bangladesh, where over 1,300 people died in 1989. So that was the deadliest tornado. And then the last one I wanted to mention was the 2011 super outbreak. So in 2011, across 6 states, there were 207 confirmed tornadoes within 24 hours, and a total of 337 tornadoes during that one outbreak, with 11 EF4s and 4 EF5s in 2011. And I don't know the number of people who died, but that was a lot of people died in those tornadoes.
Yeah, you had brought that up prior to the show, and I was like, that's insane. I don't even remember hearing anything about that, which is crazy.
Yeah.
You would think that that would have gotten a little bit more news coverage.
Yeah. Back in 2011.
Yeah.
Yeah, there was a few stories about how some of the schools didn't have their cellars and stuff proper, and people ended up dying in schools because of it,
Wow.
which was kind of crazy. To have a school without a shelter in like Oklahoma seems ridiculous, but it happened at the time, and they were hoping to use this crazy outbreak to help enforce laws to make schools in public areas have the necessary things.
Makes sense.
Yeah, so that one was pretty crazy. And
Wow.
yeah, just and then the highest temperature, because we went over the coldest, the highest temperature is actually in Death Valley, right here in California. So yeah, weird to think about. So the most rain in one 12-hour period was in Missouri, which is so weird.
Yeah.
Wouldn't you expect like the monsoons in India or something?
You would think.
So
Or Texas now, I guess.
yeah.
Sorry, not to laugh at those people's
But
expense.
yeah, and it's also the warmest in Death Valley. So
Yeah.
they had over 40 days of over 124 degrees in a row. Hottest on Earth here in the United States. So, yeah. I also wanted to bring up this point. It's cool to look at what is possible and what's already happened on Earth, but we don't have a large sample size, so we don't really know how like significant one event really is as opposed to an extreme, because we don't have that much time. It's hard to think on a time scale of the Earth when we talk about records and what to expect and what to happen.
Yeah. Do you think, Tom, I'm spitballing here, do you think that the capabilities to hopefully study Earth-like planets around other stars will increase our sample size of like what can be possible as far as weather patterns go on terrestrial like planets, and that we might get a better sense of like what is possible at the extreme bounds on our planet?
If we could get enough data from them, I think we could, but I don't think we're going to be able to get far beyond just like what they're made up of. I think that's pretty much going to be the only thing we're going to be able to get out from them.
Yeah.
Not really able to discern any atmospheric or geologic activity, really.
Not for the foreseeable future.
For
at
now,
least.
yeah. So it's tough to say. Yeah, we only really got our Earth to study.
Yeah.
For now.
Interesting.
But in the far future, who knows? But for now, yeah, it's tough with one you got one Earth and you only got a little bit of time studying it to really say what's what.
Yeah.
You know?
Well, there you have it, ladies and gentlemen. Thank you so much for joining us this evening. Of course, if you like this video, please consider giving us a thumbs up, subscribing to the channel, telling your friends about trèSci Weekly. We love that you guys are here with us, chatting with us throughout the show, and we only hope to engender more into this lovely little community that we have here.
Any science news articles that come across your way that you want to know more about, you just want to let us know about, anything like that, feel free to tag us, trèSci Weekly, or you can tag us on Twitter, our own Twitter handles, or trèSci on Twitter. Or Facebook. Or
trèScimail@gmail.com. You can just email us.
Yep.
Right? Tom quite frequently says that he's going to email people.
That used to be the joke.
Yeah.
Send you a nasty email.
Thank you guys so much. We'll be back next week with more science news. Until then,
stay safe.
Stay frosty. I don't know.
See you later, guys.